So we have video notes on solving special equations with the answers of no solution and infinitely many solutions, or all solutions. Your objective: I will be able to solve equations with one solution, no solution, and infinitely many solutions by taking video notes, studying the examples, and practicing for mastery. So here we have vocabulary: no solution. So as we talked about today, no solution means an answer where no number will satisfy the equation, where you could substitute that number back in for the letter, the variable, and make the equation true. There isn't a number. Now, some kids are a little confused today. No solution is actually the answer to an equation. So, for example, I have 5x plus 3 equals 5x minus 8. So if I go ahead and solve this equation, I do my same change opposite. All right, I'm going to have to move this 5x over to this side because we have to get the variables to one side. Notice positive 5x and negative 5x cancel, but so do these. So in the end, I'm left with 3 equals negative 8, which we know is not true. So in this case, there isn't an answer that will satisfy the equation I had to begin with. And a little later on, we'll talk about why. Infinitely many solutions. Here, every number would be a solution to the equation. So our actual answer to those types of equations would be infinitely many solutions. Kids always want to have a number answer. Well, now you have answers that are phrases. So in this case, it'd be something like this. 5x minus 6 equals, let's say, 3x plus 2x minus 6. So we're going to do our same change opposites here, and same thing over there. I'm going to combine like terms there. So I have 5x plus negative 6, and I have 5x plus negative 6 over here. So you can see that they're the same on both sides. So if I go ahead and solve this, I again have to move the variables from the right to the left, so they're on one side. They cancel, but so do these, because they're opposites. So what I'm left with is this negative 6 equals negative 6. So that's different than this ending over here. They did not equal here, but here they do. So every number that I could come up with, fraction, decimal, radical, if I were to substitute it in for these variables, would make this equation balance. All right, so previously we worked on solving equations with one solution. So we had one-step equations, then we had two-step equations, then we had multi-step equations. And you were given steps that you wrote on index cards that we're going to follow through to solve these equations. So let's go ahead and practice that a little bit. So first thing I look for is fractions. I don't have any to deal with. Next thing, I look for subtraction. I don't have any. All right. I don't have variables on both sides. So my next step is distributive property. Don't have any parentheses here. I can't combine like terms because I can't combine this positive 6 with that negative 15 because we can't cross that balance. So I'm basically left with the two-step equation. So I'm going to do opposite of the number. So a negative 6 on both sides. And then I'm going to do opposite of the operation. Negative 15 and negative 6. Remember, add. It's not subtraction. That's negative 21. And then I'll go ahead and do divide by 3. So I'm left with x equals negative 7. So I have a variable equal to one number. That means there's only one number that I could substitute back in for that variable. 3 times negative 7 is negative 21. Negative 21 plus my 6 has to be equal to negative 15. Negative 21 plus 6 is negative 15. So we see that it's true. So let's go over and do this one. I do have subtraction, so I'm going to do my same change opposite. I see that I have to do the distributive property, so outside times everything on the inside. So I have 2x plus negative 16 equals 20. And then, of course, I'm left with a two-step equation. So I'm going to do opposite of the number. All right, so I get 2x equals 36. Then I'll do opposite of the operation. So I'm going to divide by 2. So x equals 18. So again, I have a variable equal to a number. That means there's only one solution here. All right, down here, let's do this one. So here, this looks a little bit more like these problems. I had variables on both sides. So you might, right off the bat, go, hey, wait a minute. This is going to be no solution or infinitely many solutions. But when we do this actual work, we're going to find out that these variables are not exactly the same, are they? So let's go ahead and do our same change opposite. I don't have fractions. I do have variables on both sides, so I'm going to have to move one to the other side. I don't have distributive property. I can't combine like terms because, again, remember, you can't combine across. This is a variable term. This is a number term. They aren't the same. This is a variable term, and that's a number term. They aren't the same. Just remember, you can't cross the balance. So I do have to bring this 5x over to the other side. So the opposite of 5x is negative 5x. They cancel, so I'm left with negative 2x plus negative 4 equals 6. And now you notice that all my variables are to one side, which is different than what you saw up here. So they didn't cancel out. So now I just do opposite of the number, and negative 2x equals 10, and then opposite of that operation, so I'm going to divide by negative 2, and you'll notice that I do get a variable equal to a number, so that's one solution. Okay, over here, I have subtraction, so let's do same change opposite. Okay, I do have this combining like terms, so I have to combine those, so I have 2x plus negative 11 equals x plus negative 4. All right, I need to bring this x over to here, so I'm going to do the opposite of positive x is negative x. And in this one, I'm going to actually do two steps at the same time. I brought the variables to the left. I'm going to take this number and do the opposite and bring it to the right. That's saving me one step. Okay, so, oops, I'm sorry. That wasn't quite correct. So these cancel and then these cancel. So I'm left with 2x, and a negative x is x. And then over here I have negative 4 and positive 11, which is positive 7. So I have x equals a 7. So there we have all one solution problems. But now I have no solution and infinitely many. So it's very simple to tell the difference. Okay, in no solution, we're going to have variables that are exactly the same on both sides. And it doesn't matter if it's literally 5x and 5x, or if I have a problem like 3x plus 2 equals x plus 2x minus 8. I might have to do one of my steps. But as soon as I recognize that I have the same variables on both sides, the same variable term, I know that I'm either going to have no solution or infinitely many. In this case, these are no solution because look what happens. I'm going to do a negative 5x on both sides, so now these cancel, and I'm left with 3 equals negative 4, which we know isn't true. 3 is not equal. So in this case, our ending balance wasn't correct. If I have infinitely many solutions, what you'll notice is let's use 5x again, plus 3 equals 5x plus 3. You'll notice I have exactly the same variable terms and number terms on both sides. And that's whether or not I have the original 3x plus 3. I might have 2x plus x plus 1 plus 2. It doesn't look like they're the same. But after I do some steps, they are. So notice over here, I have my same change opposite. Okay? I'm going to combine like terms. So I'm going to have 3x plus 2 equals 3x plus negative 8. So right off the bat, I see that my 3x's are the same. I know that when I go ahead and do the opposite, they cancel. So I'm left with 2 equals negative 8, which we know is not true. So in both these cases, my actual answer would be to write the words no solution. There is no number that works for the variable. Okay, so what did we have here? We had the same variables on both sides, and in the end, the numbers weren't equal. So how about this? If I were to solve this, I would take opposite of 5x is negative 5x. They cancel, but so do these. And in this problem, I actually have 3 equals 3, which is true. So that means no matter what number I put in for the x's in the original equation, it's going to work. So we say that infinitely many solutions will work. I got to spell it right. Trouble with my, okay, infinitely many solutions or all solutions you could write as well. In algebra, this is called an identity equation. So now down here, don't get mixed up and say, well, gee, those variables aren't the same. Remember, you have to follow through on your steps in solving equations. So in this case, I have to combine like terms. So 2x plus x is 3x, but I also have to combine the number parts. 1 plus 2 is 3. So now I have exactly the same expression on the left side of the equation as the right. So automatically I know that no matter what I do, I'm going to cancel them out. So if I do opposite of 3x is negative 3x, the variables will cancel out because they have to. If the variable doesn't cancel out, then remember, I'm left with a one solution problem because the variable will be equal to something on the other side. So in these, the variable has to cancel out. And in this case, the number on the left equals the number on the right. So our actual answer is infinitely many solutions. If you go ahead and say, well, gee, I know the answer could be 4. Well, as soon as you say the answer is 4, that means you're saying it's only one solution. So when you get these equations that have these particular parameters, where I have variables on both sides that are exactly the same, and in this case, the numbers aren't equal, this is actually your answer, no solution. When I have the circumstance where I have the same variables on both sides and the same number terms, then this is your answer, infinitely many solutions. Right? So we'll practice more of that tomorrow, but make sure you write these down for notes tonight.